Okay, good morning, pre-calc friends. So this is our last lesson. I know that you're very upset about this, but that's, it's the way it is. I'm sorry, life has its challenges. So we're going to do obviously geometric sequences today. We did arithmetic last time. And yes, like I said, this will be the last lesson, and we'll do a review session on Monday morning, and then you can take your test Monday afternoon, and God, I hope we're done. It's going to only be on 3 sections. It'll be small. It'll be a small test. So, yeah, it should be fine. Okay, geometric sequence. So a sequence in which the ratio of consecutive terms is constant. That ratio is called, cleverly, the common ratio. All right, so let's take a look at a couple of examples of geometric sequences. So we look at 3 and 6 and 12 and 24, and we look to see if there's a common ratio. Well, let me see. So from 3 to 6, that means I could multiply by 2. 6 times 2 is 12. 12 times 2 is 24. Yep. This is a geometric sequence because the common ratio is 2. How do you find the common ratio? Easy. Take any 2 consecutive terms and divide the later one by the earlier one. So 6 divided by 3 is 2. 24 divided by 12 is 2, etc. All the same. Same trick right here. So we got negative 1/3, we got positive 1/9, we got negative 1/27, we got positive 1/81. So clearly what we're doing here is we are multiplying by negative 1/3 each and every time. So again, this represents a geometric sequence. And again, we can still find the common ratio by just dividing. So 1/9 divided by negative 1/3 is, you guessed it, negative 1/3. Okay. So here's the formula for the nth term of a geometric sequence. So the nth term is going to be the first term times r, the common ratio, to the n minus 1. Yeah, it's a pretty simple, straightforward formula. Nothing tricky about it. So let's do it. Finding the terms of a geometric sequence. So find the first 5 terms of a sequence whose first term is 4 and whose common ratio is 5. All right, so we use our little formula here. So we're going to write our formula for the nth term for this particular sequence here. So we got a sub n equals, first term is 4, common ratio is 5, and we got n minus 1. So, and you can see now, or you're going to see in just a moment, why we have n minus 1 instead of just n. So let's start with our very first term. So n equals 1. Well, I'm not going to write n equals 1, but so our very first term is going to happen when n is equal to 1. So we're going to put 1 right in here. So 1 minus 1 is 0. 5 to the 0 is 1. And 1 times 4 is 4. Well, that's the way it should be because we were told that the first term is 4. So if we do this little n minus 1 trickery right here, then we get when n is our first, when n is 1, our first term, 1 minus 1 is always going to be 0. 5 to the 0, or anything to the 0 is going to be 1. So that'll get us our first term. So that's why we got the n minus 1 trickery there. All right, and then we move on to number 2. So 2 minus 1 is 1. 5 to the 1 is 5 times 4 is 20. Things are going to get tricky here really fast. We're on to the third term. So 3 minus 1 is 2. 5 squared is 25 times 4 is 100. And 1, 2, 3, 4. 4 minus 1 is 3. 5 to the third is 125. Times 4 is 500. Here's where things are going to get a little trickier. So 5 minus 1 is 4. 625 times 4. Let me just do that math over here quickly. 625 times 4. 0, 2, 8, 10, 0, 1. Oh, I should have got this. This is 2,500, right? Yeah, 2,500. 2,500. So there you go. There are the first 5 terms of the geometric sequence, whose first term is 4, common ratio 5. Simple stuff. Okay, so find the 20th term of a sequence whose first term is 12 and whose common ratio is 1.2. Sure hope I can find my calculator. Where else would it be? It was on the floor. Okay, so let's do this. So we know the nth term a sub n is a sub 1, the first term, r to the n minus 1. So if I want to know the, where is it, the 20th term, I'm just going to put 20 right in here, and all the other stuff. First term is 12, and the common ratio is 1.2, and so we're going to do 20 minus 1 is 19. So 1.2 to the 19th power, 1.2 to the 19th power equals, multiply that by 12, boom, and we got 383 point, we'll call it 38, 383.38. There's not a repeating sequence of numbers after the decimal point, so I just rounded it to 3, so 0.38. So there it is. Just plugging the numbers into the formula. Pretty simple, pretty straightforward. Okay, so find the 12th term of the sequence, blah. So the only difference with this one as compared to the other ones is you just got to figure out what the common ratio is, and obviously the common ratio is going to be 4. So again, we have our little formula here. So we're going to have 4 times, in this case it just happens to be that the first term and the common ratio are the same, it doesn't have to be that way, to the n minus 1, and in this case n is 12, so we're going to do to the 11th power. Oh god, this is going to be a giant number. Should have thought of that earlier. 4 to the 11th power, oh, that's not too bad, times 4, which is really just 4 to the 12th power, right? So we get 167, 772, 16. 167, 772, 16. 167, 772, 16. Yep. 1, 2, 3. 1, 2, 3. So 16,777,216. So there it is. Again, this is all formula work right here. Easy stuff. Okay. So, well, here there's going to be a little bit more work. So it says the 4th term of a sequence is 360. The 8th term is 4 and 4/9. Find the 10th term. So what we need to do is we need to find our common ratio, and I'm going to pause right here because I need to use the restroom. I'll be right back.